Hey there YouTube, this is Jimmy with To The Top Crane. Weather's been kind of uncooperative this last week or so. Haven't gotten much footage, but we just got back off of a job. We had to do it at a local ethanol plant, and they've got a policy for no cameras inside, so unfortunately I wasn't able to get any footage for you guys on that. I have to be sensitive to our customers that have policies in place to protect their proprietary systems and also their proprietary way of doing things. So there are several places that we can't get any footage in them even though we go in and do the work. But since I was kind of lacking a little footage on some crane work, I figured I would do another repair video for everybody. Right there's our 100-ton crane, and this is the back end of our 200-ton crane. But anyway, we've been having a little bit of an issue with this 200-ton crane ever since we got it. It's an intermittent deal. I'm gonna get in here and show you guys what goes on behind the cab. So here's our operator's cab on the crane portion. I apologize for the camera shake. I'm holding this thing with my little magnet mount that I homemade. Back in here is some more hydraulic controls. If you watched our other video where I replaced that valve for the telescope locking out, that's on the opposite side of the crane. But we have more hydraulics on this side. So I'll point a few things out while I got this camera up, and then I'm going to explain to you guys what I'm going to do. So naturally, here's our fuel fill for the fuel tank for the upper. This is our swing motor. This is what swings the whole crane whenever I'm swinging right or left. And it goes through a series of planetaries. So that thing's got a huge gear reduction by the time it goes through all these planetaries. And then it has a little pinion. Let me see if I can get the light down here so you can see it. Has a little pinion gear on the bottom. And then that pinion gear engages the swing gear, which is on the turntable, around the whole circumference of the turntable. So I'll get my light put back up here. The issue that we're having is sometimes when we're working this crane hard and it's warm outside, or we do a lot of extending and retracting, picking up our counterweights and whatnot, the hydraulic oil warms up, but it also I'm having trouble with this valve. What it's doing is my swing brake won't release, and I have to let it sit for about 10 minutes until this little coil cools off, or this valve cools off. That's what I think it is. It's got to be heat related. You can see this coil here, it's black, unlike everything else that's been painted. So I had it actually stick on me on a job, and I pulled that coil off, and I felt the stem, and I'll show you guys on the new coil how all that goes together and whatnot. But the stem was so hot I couldn't hardly touch it. And anybody that knows me personally, having turned wrenches on heavy equipment outside over the last 20 some years, I've got somewhat reduced feeling in my hands anyway. I mean, I can take a pan of biscuits out of the oven and just start taking biscuits off of the cookie sheet barehanded, or I can almost reach in and pull the pan out of the oven. So for me to be able to touch, or for me to touch that stem and have it be so hot I can't hardly touch it, that's pretty hot. So anyway, I'm gonna shut the camera off for a second. I'll get the new coil out and I'll show you guys how it works, maybe try to explain some of it. Hopefully it doesn't go over anybody's head. I try to describe stuff in enough detail that even a layman can understand it. And then I'm also going to talk about a couple other things in this system for anybody that is going to work on their own hydraulic stuff. So yeah, I'll be back on in just a second. Okay, I've got our new coil, and new valve. So I'm going to try to explain how this works, and like I said, hopefully this doesn't go over anybody's head. The way this operates, you can see the ports around it. That is where the oil flows in or out or through the valve and inside that manifold. Inside the end of this, I'm hoping you can see, I know my lighting sucks and I apologize, but I'm hoping you can see inside there, there's a spool, and that spool actually slides back and forth and closes or opens off these ports. Now the way it does that is on this stem, that spool actually extends up into the stem, and it's basically ran by an electromagnet. What I think is happening is these spools are machined to, I don't know what the tolerances are, but it's less than 1/1000th. So that's less than 1/1000th of an inch. A human hair, the average human hair, I've measured it before, at least on my head, is about 4/1000ths of an inch. Well, that's back when I had hair. So to give you an idea on that, if it's machined to less than 1/1000th, and my human hair is 4/1000ths, then that is less than 1/4 of the diameter of human hair. That's how tight a tolerance these are machined to. So what I think is happening is when this system gets warm, this spool is not being able to retract completely up into this stem, and in doing so it gets it hot. So just a solenoid or any kind of electromagnet, if it has a piece of metal, or on an electromagnet there'd be a plunger that goes in and out of here, or a solenoid like a fuel control solenoid. If that stem cannot retract completely into the center of this coil, then this coil will overheat. So I think what's happening is it's not retracting completely in here, and it's getting it so hot that it's causing it to stick, and then when it sticks I can't release my swing brake, so I'm just stuck. I'm stuck for 10 or 15 minutes until it cools off enough that it starts functioning again. So anyway, we're going to replace this coil and hopefully that problem goes away. Now, before I take this coil out, and you can see that it's my magnet stuck. You can see that it's screwed into the bottom of this manifold. So that manifold controls the swing brake and also my counterweight system for raising and lowering my counterweights and locking and unlocking my counterweights. On this circuit, on the swing circuit, if you look over here, and I'll tell you what this is, and I'll tell you how I know that it's on the swing circuit. This is a hydraulic accumulator. So inside that accumulator, and on the front half, the side where the hydraulic line's plumbed into it, well, let me back up a second. This accumulator has a bladder inside of it, so it looks like just one solid kind of football shaped whatever vessel, but it's actually not. It's one solid vessel, but it's divided with a high pressure bladder. So there's oil in one half of it, and on the back side, and I don't know if I can get this stuck up in here where you can see it, but there's a charging port for nitrogen. So you add nitrogen to that bladder to a certain pressure, and what that accumulator does is it maintains a pressure in the hydraulic system. It can maintain that pressure even with the engine off. So the reason why it's important to talk about this accumulator, if that accumulator has system pressure in the system right now with the engine running, and I take that valve out, it's going to dump the oil from that accumulator out through that port at system pressure. So in my other video I talked about the dangers of getting hydraulic oil injected into your skin and whatnot. That is a very real possibility with an accumulator in the system. So you have to take appropriate measures if you have an accumulator to protect yourself from that pressurized oil. One of the things you could do, and you can only do this if you have a way to recharge that accumulator, is you could actually purge the nitrogen out of the back, and that would relieve the pressure of the accumulator to a certain degree. It may not get it all out of there, so it still may have some pressure on the front side of it, so you still have to be mindful of that. Fortunately, on this system, what that accumulator is used for is when I have this in the dolly, this brake has to be released. So there's a swing brake in this system right here. So what that is, there's a piston inside here that can go up and down, and it pushes on some friction discs and this, that, and the other. I won't get into all that too deep, but that accumulator maintains system pressure inside this brake after I close this valve and this valve. So that holds the swing brake off so I can steer while the boom is over the back and in the boom dolly. So in theory, at least my theory, if those valves isolate that accumulator pressure during dolly travel, then I can isolate that accumulator to take this valve out just by closing those valves. So that should lock that accumulator circuit out from that manifold. Hopefully that makes sense and doesn't seem like rambling, but it's very important for everybody to understand that if you see one of these in your hydraulic system, you better pay real attention to what you're doing, or you could end up with a bad situation real quick. Now, I'll talk a little bit about why they put accumulators in. Sometimes they put them in systems to like smooth out your hydraulic functions, or if a pump is just marginally big enough, they can add an accumulator, and what it does is when the system isn't requiring a lot of demand, that accumulator actually maintains its charge at system pressure. And then if something happens to where you run a function and the pressure drops below accumulator pressure, then that accumulator can start dumping its oil into the system to maintain a steady hydraulic pressure. That's one of the main reasons why accumulators are installed in hydraulic systems, is it just makes them run smoother. You don't get quite as much jerkiness out of the system. But they can also use them, like I said, on this case, to store system pressure, to keep something released. I'll also show you on the suspension system on this crane, it has accumulators, and those are actually used as part of the shock absorbing system. So when I get done with this video, I'll give you a quick peek at that, because for the suspension it's just hydraulic cylinders. Well, everybody knows that fluid's not compressible, so if you just locked oil into those hydraulic cylinders, this crane would be riding on rigid suspension. Well, what they do is they divert that oil out of the cylinder into a circuit with an accumulator, and that bladder in the accumulator with the nitrogen charge on the back side of it acts as a spring, so it allows that oil to transfer in and out of the cylinder under accumulator pressure. Another quick note, if you do lose accumulator pressure or nitrogen pressure out of the back side of that, you can see that sticker. Let me see if I can get in close to it. It says do not use oxygen. Well, if that bladder were to rupture, you just shoved a bunch of oxygen in your hydraulic system, and then you could have created an explosive environment. Also, you cannot charge that up with your shop air compressor. I mean, I've heard of people trying it. Do not put air into the back side of that accumulator. It's nitrogen only, and it's to a certain spec. So if you do dump your nitrogen, you need to make sure that you look up the specs and recharge it with nitrogen back to its original factory spec. So anyway, we've covered 10 minutes of hydraulic safety and electric solenoid valve theory and whatnot. I'm going to get this camera set up. I'm going to get this valve out of here after I close those valves up top. I don't know if you can see them or not. I apologize, my lighting's terrible. It's just a drop light. But we're going to get that valve out of there, get the new one in it, fire it up, make sure that we still have swing, and see how it does on the next time out. Okay, hopefully everybody can see that fairly well. I'm getting ready to pull this valve out. So, cover a few things that we covered in our other video. Yes, gloves. There still could be just a little bit of pressure in here, and also I don't necessarily want to get hydraulic oil all over my hands. Second thing, eye protection. Anytime you're messing with hydraulic systems, eye protection is a must. So first thing we got to do is get that coil off of there. A lot of times they're just a little finger screw down here on the bottom, or finger nut. This one had some paint on it. Use some little slip joint pliers, or adjustable pliers. Actually, small water pump pliers is the technical name for them. Everybody calls them channel locks, but so we're going to slide that coil off, pull the retainer clip, hang on to that, don't lose it. And I'm going to save this coil. As far as I know, I'm going to replace this coil, thinking maybe the coil was going bad, but I'm going to save it just in case it was still functioning when it was cold. So now we got that out of the way, we are going to loosen that stem, or that valve, and also touch on something real quick before we get real deep into this, before we pop that out of there. Cleanliness with these spool valves is utmost importance. We talked about those tolerances being really tight. One little bitty piece of dirt in there can jack the whole thing up. So we're going to see how easy this is to break loose. Shouldn't be too bad. We are going to screw this thing out slowly, especially till it gets to the O-ring, or when the O-ring's exposed. There's a series of O-rings that seal this into the block. If you're wondering why I'm kind of going at this somewhat slow, you don't want to just start ripping stuff apart when you're messing with hydraulics. If there is pressure in there, if you go nice and easy, a lot of times it'll present itself as a drip before it turns itself into, like, actually, you could have enough pressure in there, you could turn that valve into a projectile. But also, if it's gonna leak any oil, if you go slow, it'll be a drip before it turns into a spray and soaks you with oil. I've taken oil showers, they suck. Not only do you have to drive home covered in hydraulic oil, you got to worry about getting that stuff all over in your vehicle, and then it's kind of a pain to wash it off of you. It takes pretty hot water and pretty good soap, but it does make your skin soft. Okay, so we got a little bit of oil that's dripping out of there. And it still feels like it's got a little bit of tension on it. So since it feels like it's got a little tension on it, it could be a few things. It could be the O-rings inside that are still providing a decent seal, but it also could be the fact that it has a little bit of pressure in it. So we're gonna slow down a little bit. We're gonna let that drip for a second. By letting letting it drip. If there is some pressure, we're relieving some of it. Which is another way that if you don't want to discharge the nitrogen out of your accumulator, if you're very careful, you can let the pressure out of the system by opening or cracking a line on or cracking a fitting on a hose, or you know, anything that's on that circuit. You just got to be cautious when you do it. Okay, so now it's spinning pretty freely. That tells me that there's probably not any pressure behind it. It's just what it's dripping is it's dripping the oil out of that block. So I'm going to go ahead and switch over to fingers and spin that out of there. Get myself in a comfortable position here where I can kneel on this tread plate deck. So this new spool valve, it came with a rubber protective sleeve over it. You want to leave that on there until you are ready to install it, or pretty close to ready. Don't lay this down anywhere. Okay, so I'm going to drop the old one, switch hands with this one because I can't get my shoulders up in here, and shove the new one up in it. Another tip I'll cover too, if you're messing with fittings with O-rings on them, it's a good idea to lubricate the O-rings when you're putting stuff together so they don't tear themselves when you're tightening stuff down. I obviously didn't need to do that on this one because that was pretty self-lubricating. And one thing you'll probably notice about me is, one, I talk a lot, and most of the time when I'm operating the crane I edit that out because I'm fast forwarding. This crane works generally pretty slow. And two, I may switch gears in the middle of a sentence. I don't know if that's just because my brain's moving faster than my mouth or what, but sometimes I tend to do that. And I do everything, I record everything first take. I don't, if I say something that I want to change, I don't back up and edit it out. And all my stuff is first take, so what you see is what you get. I'm kind of one of those, you can love me or you can hate me, and either way I don't care. I'll do anything in the world for anybody that's willing to help themselves. But I legitimately don't care what other people think about me for the most part. So I'm gonna snug this thing up pretty good, or pretty tight. That's pretty good. That's not really a torque value. Tight isn't even really a torque value either. But you gotta kind of feel what's going on with it. You're screwing this into an aluminum block. If you strip that out, that would be very expensive. I can tell you, just that spool valve is 600 bucks. So I can't imagine what that manifold costs. Okay, you'll see that there's a couple O-rings here. These green O-rings. These green O-rings, they don't seal anything that has to do with oil. All those are for is to keep debris out of that area between, the coil and the stem on that spool valve. Keeps dirt out, keeps moisture out. Wipe some of that excess oil off, but I'm not going to get too carried away. It won't hurt to have a little film of that oil in there. Change the coil. And I gotta try to get this up in here. I can barely get my shoulders in here. And then I'm gonna snug that up just a little bit with the pliers. I would generally just finger tight that, but I got gloves on and they're covered in oil, so I couldn't get a really good grip on that. You should still be able to turn this. Now it's a matter of just reconnecting our electrical connection. Ooh. That evidently needs to be indexed the other way. Almost screwed up there. I don't think it would affect the functioning, but why risk it? That went on a little better. And we will snap our little retainer on. Actually, it'd probably be easier to do it out here. It should just slip right over it when we go to put it together. There. That was easy. We actually lost more oil on this deal than we did replacing that big valve for telescope. Anyway, I'm gonna clean stuff up. I'll start the crane up. We're inside the shop, so I can't do a whole lot. But make sure our swing brake's releasing. Yeah, I'm gonna talk about one other thing real quick while we're in the middle of this coil replacement, this valve replacement. So this thing goes together like this in your system, and these are common on a lot of machines. This isn't just crane specific. I mean, there's log splitters with these, there's lawnmowers with these. They're common. You'll find them about anywhere that there's electric over hydraulic, or if you have an electric switch that does something hydraulically on your machine, this is what it's using to do that. When you're doing your repairs in and around these coils and whatnot, you don't want to go swinging a hammer in the vicinity of these. So this coil's sitting on top of this stem and on this valve, and if we knock this coil off of here, so you have this stem sticking up, that's where the coil sits. Well, that stem is attached to the spool, there's a piece inside that stem that is attached to the spool that allows that spool to open and close. So if I cut this thing in half, you'll find a steel rod. Sorry if I'm panning out of view, my viewfinder went blank. But if I cut this in half, there'll be a steel rod in here connected to the spool, and that coil will pull it one way or the other, push it, pull it, whatever. If you bend this stem by whacking something with a hammer and whatnot, even if you bend that thing by a few thousandths of an inch, this will fail to operate correctly. So when you're trying to crack your hydraulic lines loose, we'll see if we can see some up in there. There's hydraulic lines all over around those valves. If you go beating on stuff with a hammer or a big wrench or whatever, and you miss your target and you hit one of those coils and bend this stem, you would be in for a little bit more expensive repair. And you probably won't find it until you go to operate your machine and you realize that something's not doing what it's supposed to do. And then you got to go back and hunt it down and find out which coil you destroyed with a 3-pound hammer, or which valve. So I figured I'd talk about that real quick too while we're in here. I try to be as informative as possible and upfront. Definitely try to be safety oriented. But yeah, there it is. So we replaced the spool valve, coil, all on the swing brake circuit, and hopefully now everything will operate the way it's supposed to, regardless of how warm it is outside. Okay, so I told you earlier I'd show you a little bit about the suspension on this. Well, I had some stuff out. So here's the top of the tire, obviously. I apologize, everything's dirty under here. This thing needs a bath. So there's our cylinder that raises and lowers our suspension, but that's also the entire suspension system's way of absorbing road shock and bumps and traversing uneven terrain. So that hydraulic cylinder has to be able to move up and down at basically its own free will. The way it does that is, looky there, another accumulator. See if you can read this tag. Try to get rid of some of the light. Really, all you need to see is the big yellow caution. But it says to release all hydraulic and gas pressure before disassembling unit. Typically, if there's a sticker on a machine and it's got yellow and caution with a triangle and an exclamation mark in the middle of it, you better be pretty careful or you're going to do yourself some harm. Then there's all the valving for the suspension system. That's what allows me to raise it and lower each side independently, or front and rear, or one corner. Or also locks the suspension if we have to move around on a job site with all the counterweights on. Does a host of things. So anyway, there is the suspension. Well, part of it. That's just for the left rear 2 axles.